Okay, so number one, we've got to graph this. It says to make sure we have at least 2 points. I talked about 3. Since it says 2, I'd probably accept that, but plug in -1, we get 1/3 times 4 is 4/3. Plug in 0, 3 to the 0 is 1 times 4 is 4. Plug in 1, 3 to the first is 3 times 4 is 12. I don't know if that one's even going to fit. But -1 and 1 and 1/3. 0, 4, 1, 2, 3, 4, 7, 8. Now, yeah, the other one won't fit. So I'm going to, the asymptote hasn't been shifted, so I'm going to jump to that, which is really part C. But we would say that y equals 0 is our asymptote. And so I'm going to come close to that, hit the points, and then get steeper as it goes. So it's going to look something like that. Domain and range. Domain is going to be all reals. Your range, since the asymptote is at 0, it's going to be y is greater than 0. B, transformations. Didn't go left, right, or up, down. The 4 is going to stretch it vertically. And D, growth or decay, that one's growth. Our growth factor, the number that was raised to the exponent was 3, which is larger than 1, that's growth. Number 2, so to the -1, 1/2, that's really 1/2 to the -1. The reciprocal of 1/2 is 2, so it's for 3 times 2, which is 6. Then we get 3, and then I get 1.5. There is no k value at the end, so there's a y equals 0 for an asymptote. So we can draw something like that. Domain, all real. Range, it's greater than the asymptote, which is 0. This one is also stretched vertically because of that 3, or a vertical stretch. But no translations. And then this one, decay. The growth factor is less than 1, and it's getting closer to the asymptote, so that one's decay. All right, so for -8, -2, -1/2. Horizontal asymptote is 0 again, so approach the x-axis. Don't touch it, don't go across it. Domain, all reals. Range, this time we're below, so it's y is less than the asymptote, which is 0. It is reflected across x-axis. I run out of room here. And stretched vertically. No translations. And it is decay. The growth factor, it's less than 1, so it's decay. It's coming from below, but it's approaching the asymptote, so that makes it decay. So here we've got a k value. I'm going to think about the parent function. So no k value, and then I'll adjust. So 1/4, 1, and 4. Then, because of the -2, that's a k value, we're going to subtract 2 from the y's. So we get -1.75, -1, and 2. The asymptote, because it got shifted down 2, is at -2. So I'm going to put a dashed line there at -2. Make sure I don't cross that. So I'm going to approach it from the one side, and then the other side. I'm going to head up through those points. All right, and domain, all reals. Range, we're above. but it got shifted down to -2. We're above -2. This one went down 2. That's the only transformation. It is growth. Alright, so parent function, I'm going to keep the a value in there. So 2/5 times 1/2 to the x. I'm going to ignore the h and the k for the time being. So we get 4/5, which is 0.8. We get 2/5, which is 0.4, and then I get 1/5, which is 0.2. We're heading 1 to the left. And actually the 2/5, since that's less than 1, it's going to compress it. Instead of stretched, compress vertically. Now we're going, right. I don't remember if I said left earlier, but we're going right 1, and we're going up 2. So adding 1 to each of the x's, so we get 0, 1, 2. Add 2 to all the y's, so 2.8, 2.4, and 2.2. The asymptote, the k, which is 2. It is decay. Domain is all reals. Range y is greater than our k value, which is 2. Go ahead and approach the asymptote on the one side, and then it's kind of going gradually. And the last graphing one, the parent function would be y equals 2 to the x. Make our table of values based off of that, -1, 0, and 1. We get 1/2, 1, and 2. But then I have to subtract 5 from the x's because it's going left 5. So -6, -5, -4. There is no k value, so the vertical asymptote is at 0. Hit those points and start to head upward. Domain would be all reals. Range would be y is greater than 0. And this one is growth. Okay, then we get into word problems. Initial amount, 12,000. It doubles, so it's growing each day. Exponential function. So our growth factor, it's doubling, or it's growing by 100%. We're multiplying it by 2. Our growth factor is 2. It would have been, when we do 1 plus 100%, so 1 plus 1 equals 2. That's our growth factor there. Then part B is saying, now plug in 6 for that. I don't know how you can see the calculator here. 12,000 due to the 6th power. So we get 768,000 bacteria. Number 8, cost of tissues. It's increasing, so it's going to be growth. Initial amount was $50. 1 plus 0.051 when we change it to a decimal. For t years, so there's our model. Now on part B, we need to go ahead and plug in 25 into that. So 50 times 1, I really could just call it 1.051, that's what I get when I add those. To the power of 25, $173.40. Number 9, you buy a new bike, 1,500, it decreases, so it's going to be an exponential decay. 1 minus 0.22 t years. What's it worth in 3 years? could have also put that as 0.78 is what you can use to subtract that. But $711.83. It's a pretty exact number. Really, it's probably not necessarily going to be exactly that. Now let's flip to the back side now. Exponential function, so our initial amount is 7. Here's our x, here's our y, that's our a. So we're going to go with 28 equals 7 times, this is going to be my my growth rate. I don't really know what it is. It's 1 plus r, 1 minus r. In this case, looks like it's actually decreasing, so this decay, it's 1 minus r, but I'm going to replace it with just a variable. I don't want to use one of the ones I've used, so I could use a g for, or I guess that was a q, I meant to say a g for a growth rate. You can do whatever you want there, but we're going to try to figure out what that is eventually. And this to the power of x, which is -2. So first step is divide by 7. G to the -2 is really 1 over g squared. So I can put that 4 over 1, I can cross multiply. 4g squared is equal to 1. Divide by 4g squared is equal to 1/4. Square root. We're going to have to worry about the negative because it's not exponential if it's negative. So square root of 1 is 1, square root of 4 is 2, so we get 1/2. So now my equation, y equals 7 times 1/2 to the x. Number 11, 40.5 equals my initial amount, which is 1/2, times whatever variable I want to use there, g to the power of 2. I'm going to multiply by 2 because of that 1/2, giving me 81 equals g squared. Square root of that, we get g equals 9. So then my equation, y equals my initial amount times my 9 to the power of x. Number 12. 12 is equal to my initial amount times, I'll use my g again, to the power of x, which is 1. So that's just g. I divide by 15. 12 over 15 simplifies because I can divide them both by 3. So I get 4/5 equals g. So now my equation is y equals my initial amount times my growth factor with 4/5 to the power of x. Solve. Number 13, they're both powers of 2, so I've got to change 4 to 2 squared. I have to change 8 to 2 cubed. Both of those already had exponents, so I have to distribute my exponents. So 2 to the 2x plus 2 equals 2 to the 6x plus 9. Now that we have the same base number, set the exponents equal to each other. Subtract your 2x. Subtract your 9, divide by 4, -7/4 is my solution. Number 8, these are both powers of 2. So we go 2 to the 3rd to the x minus 2. 16 is 2 to the 4th, and since it's in the denominator, I want to move it up. I'm going to make that exponent negative. I guess it's not 2 a power, so I don't really need those parentheses there. Distribute my exponent on the left side, so 3x minus 6. So now 3x minus 6 is equal to -4. Add my 6, divide by 3, I get 2/3. Number 15, they're both powers of 3. 9 is 3 squared. 27 is 3 cubed. Distribute. Distribute over here. Now we can set the exponents equal to each other. 2x plus 2 is equal to 3x plus 12. I'm going to subtract x from both sides, subtract 12. I get that x is -10. Now we get into inequalities. I do the same process. 49 is a power of 7. I've got to distribute there. Now I can get rid of the base numbers. I know that 3x has to be less than 2 minus 2x. I would add 2x to both sides. and then I can divide by 5. X is less than 2/5. Number 17, these are both powers of 6. 36 is 6 squared, but it's in the denominator, so it's really 6 to the negative 2. To the 6x minus 3, I'll have to distribute that in a moment. The right side doesn't need to change yet. Distribute, negative 12x plus 6. So negative 12x plus 6 is greater than 3x minus 9. So I'm going to add 12x. I guess I'll add 9 also, giving me a 15. Divide by 15. I want to switch the order because I like x on the left side, so x is less than 1. Number 8, both powers of 5. Distribute. So now 2x is less than 3x minus 15. Subtract your 3x. Divide by negative 1. That flips the sign because it's an inequality. X has to be greater than 15. Okay, number 19. You're investing money. It's compounded semi-annually, so it's going to be twice a year. So we're investing $20,000. Our rate is 5.2%, so 0.052. Semi-annually is twice, so we're dividing that by 2. And then my exponent, because I'm getting interest twice a year for 3 years, 2 times 3, that's a total of 6. So let's plug that in the calculator. $23,329.97. Number 20, you borrowed money. What will you pay back? That's compounded annually, so it's not really, technically it's not compounding. If it's compounded annually, it's only once a year, so we can just use our growth. I don't need to, sorry, I was going to make a fraction because I was ready to do compounded. Because it's annually, I'm not going to worry about it. So 1 plus 0.11 to the power of 2. So 59,000. 1.11 squared. $72,693.90. So 72,693.90. Number 21, compounded quarterly, so we're getting interest 4 times a year here. So we've got 40,000 initially, 14% interest, that's really good. Compounded quarterly, so we're dividing it by fourths. Now, we're getting interest 4 times a year for 6.25 years, so 6.25 times 4 is 25 times, so we're getting interest a total of 25 times. So we've got 40,000, 1 plus 0.14, divided by 4, to the power of 25, $94,529.80. Number 22, compounded monthly, we're getting interest 12 times a year. $440. 0.058 monthly. We divide that by 12. We're getting interest 12 times a year for 8 years. That's 96 times. So last one, let's plug it in. 440. 1 plus 0.058 divided by 12 to the power of 96. $699 even.